Okay, so thanks very much for having me today. I know that this is a Polish kind of a national conference for networking people, so everyone who is non, let's say, Polish speaker does not get maybe full attention, but thank you very much for spending this 45 minutes here, and I will try, I will do my best to make the worthwhile investment of your time in this conference, because I know here that I have also competition of a couple of neighboring sessions. So my name is Djordje Vulovic. I'm working for Cisco. I was working as a consulting system engineer. Now I moved a little bit to the architecture role, and I will be showing you today one way how you can actually deploy network programmability in practice. So there are really now numerous ways how you can do it. Some very low level, like using some REST or RESTconf or netconf APIs directly to the network devices. Some fairly high level, but now we will present one topic which might not be that frequent for the networking people, and this is the use of some popular orchestration tools coming from the system administrator's environment for the use of automating configuration of networking devices. So today, we will not talk about tools like Puppet or Chef, although they can be used in certain environments, but we will actually talk about the Ansible, one, I would say, quite popular automation and orchestration tool, and see what we can actually do with him with Cisco devices like IOS or IOS XR, which we will have in the demo. Just for you to know, this session is going to have only a few slides and a lot of examples and a lot of demonstrations. So hopefully, because I heard some, let's say, comments that people here maybe would not like to have that much marketing, but some kind of real stuff instead. So I believe you that, I'll try to get 0% of marketing in here. So just kind of a quick chat. How many of you have ever worked with Ansible? Okay, that's a fair amount. So you will probably know most, if not all of this. But for the rest, let's go very quickly. Just to the introduction of Ansible. So Ansible is an open source software. That's very important. This is why people love it, because it's basically free. You can just download it from the GitHub and start working. So it was built to automate provisioning of certain steps you found in the typical Linux administration environment. So either you automate copying files, making creating text files out of the template, installing packages, starting or stopping some different kind of services. The Ansible company was acquired by Red Hat a couple of years ago, and Red Hat, and you probably know this, Red Hat is 100% open source company. So they actually, everything what they develop, they put publicly on the GitHub, which they can use. But if you want to use it in your production environment, you can actually buy kind of a product, from the Red Hat. So you can actually operate Ansible in a pretty, strict production environment. Why Ansible gained its popularity is mainly because it's agentless. This means that you don't need to install anything on the device you want to manage. Contrary to the tools I mentioned, like for example Puppet, which does need the daemon on the separate daemon on the managed device. Actually, the Ansible assumes very little about the devices he wants to manage. He expects that it is able, so it was built in a way that it is able to do SSH, to copy some Python code and execute Python code on the remote device. And here you immediately see some kind of a problem that can arise for managing typical networking devices rather than typical servers. You cannot just I mean, you can SSH to the Cisco IOS router, but you cannot just transfer Python code that execute Python code, because I mean, in many cases, you will not find a Python interpreter on this box. So this is one of the peculiarities that, let's say, needed to be solved. So actually, Ansible works pretty simple. You have kind of a control station, and you have these scripts which Ansible calls playbooks. So playbooks are basically text files which are written in a kind of a, let's say, a language we called YAML. And in YAML, you will see that they express all the statements that need to be done to the certain number of the managed devices. So from the control station, it's in typical situation, the Ansible copies this module to the devices and then execute these tasks. And you will see how it differs in here. Because we will be looking at a lot of Ansible playbooks in a moment, let's just get some basic terms and definitions. So the playbook is a basic executable unit. So you build the playbook, and then you have a command for executing this playbook. You can use it via GUI, you can use API to execute it, but here we will show how it's being done on a traditional command line. So one playbook is comprised for one of more so-called plays. So what the plays, let's say, is about is specifying what to do for a certain number of hosts. And this was very easy and very natural for the Linux, let's say, server environment, where you just said, okay, to the web servers do that, to the app servers do that, to the database servers do that. In the networking, you'll see it's a bit different, because we will not use such a construct in, let's say, in most of the cases. Within play, we have a number of tasks which are executing one by one at a time, like in a sequential manner. And each task is a call to an Ansible module. And Ansible module is the most important thing. It is something which really it is a, let's say, kind of a function which really does something. Either something on the operating system level, either on some application level, either on some networking device level, or some, for example, hypervisor level. So the let's say probably one of the biggest values of Ansible in today's form is let's say a fantastic breadth of different modules that are coming out of the box. And actually, we will be demonstrating just like this. So Ansible, by default now, comes from with pre-built modules for many different, let's say, networking devices and networking vendors out there, including Cisco ones. So this is how the let's say, some very simple playbook can look like. So YAML is a pretty, let's say, kind of a human readable format. So more or less, all you need to know, for example, that this dash means list. So it's each dash is another entry in the list, and within the dash, it are just different key value pairs in there. So it's almost kind of like a list of key values in a kind of hierarchical format. So here, there are some keywords in there. So within a play, so the hosts where we defined where we want to execute something, we can define some variables in here. We can also do it later or something like that. Ansible, and you will see that in the examples, deploys a lot of programming constructs. So you can do if, thens, you can do for loops, you can do while loops. You can then do different things with the variables itself. So within the tasks, there is a list of tasks. Each task can have its name. It's pretty helpful if it has. It's not mandatory. And then it calls an Ansible module. So the first task here calls Ansible module YAM. YAM is probably most of you know actually the program, let's say the framework for the installing new packages on the server. Then the second task is calls Ansible module called template, which actually instantiates text file based on the certain template that you have built. And you will see that this is something which we are going to use pretty extensively in the networking environment. And then you have, for example, the service module, which does. So actually, all of these modules somewhere in behind maps to a different Python code, a certain, let's say, framework of Python classes and Python functions, which then does something. You can write your own, but I would say that the biggest value of Ansible is that you don't need to do that. I mean, you can use it more or less out of the box when it comes. So let's get down to our use case for Ansible, and we will actually see two use cases if I properly manage the time. First one will be to orchestrate or to provision network devices by directly accessing device. So when you look at the Ansible modules, you will find the support for almost all relevant Cisco operating systems. So iOS XE included is in iOS, then IOS XR, what we are going to have in this demo, and also NXOS platform. You can have, there are also modules for some other Cisco platforms, like for example, Cisco ACI or something like that. Within each of, let's say, these network operating system types, like iOS, then you have different Ansible modules, and there are probably something like 20, 30 different Ansible modules for different functions, what you can do to device. Let's say the most important one, which we're going to use in this demo, are the modules where you actually execute remotely some command on the iOS or IOS XR, so this IOS XR command module, and where you actually configure something, and this is the IOS XR config mode. So, in a typical situation, how the Ansible playbooks are structured, and you will see that there will be, really a couple of explanations about, how you can do it actually in networking environment. It's not, let's say, 100% straightforward. You can, find a couple of ways to do it. Ansible will actually not directly first SSH to the networking device itself. It will SSH to the local server, to the local management host. And then there execute the module from the local host. And then module will, using some Python SSH libraries, connect from your management station to the networking device. Meaning that from the Ansible perspective, you are not managing a range of devices, you are just connecting to the local host. And this is different. You will see it's not a mandatory, because in the IOS XR, you have certain functionalities where it's called the third-party namespaces, which you can actually enable SSH server on the box and have Python interpreter on the box. And in the certain cases for the IOS XR, you can use kind of a traditional Ansible framework. But since this might not be the case in, let's say, all circumstances, especially about iOS devices, I will kind of stick to this module. So this is probably one of the simple playbooks you can imagine in here. So the playbooks has only one play, and this play is coming to the local host with the local connection. So it's more or less telling Ansible to let's say, use the local host as a destination for the SSH and the playbook execution, playbook code execution. And then we here statically defined some parameters which are, let's say, necessary for accessing the device. So this is the IP address, and these are credentials, username and password. So within the task, we have two tasks. First one is where we actually execute the IOS XR command. So note we don't have a name, so it's not probably something which you would use in production, but it's okay for example. And each Ansible module, and you look that into the documentation, has certain number of possible parameters. Some are mandatory, some are optional. So IOS XR command, as most of the iOS and IOS XR modules, have this provider argument, which actually is let's say, structure of 3 values: the host, the username, and the password. I mean, the minimum. Maybe the, for example, you can specify the SSH port if it is not 22 or something like this. So here, and then you see already some peculiarities of Ansible, which you may like or you may not like. And this is, for example, how you actually specify the value of a certain variable and map it to another variable. It is something much more complex that you would do in a traditional programming language like Python. However, if you, for example, have used Djordje 2 templates, which actually Ansible uses, and we will see a lot of them during this presentation, this might be very familiar to you. So it's probably either or. So either you will like it very much, or it will be very hard for you to get in. But this is kind of Ansible. So the way how to let's say do many complex orchestration tasks without actually developing your own code in some high-level programming language. So the commands parameter has the commands, and here we didn't specify the command in the playbook because we want to give the command as an argument. So we want to execute arbitrary command. And then debug task is a kind of print, if you have ever programmed in C or C++, or print in any other language, it will just show the value of the certain parameter. So register is actually the parameter where we the output here is the variable which will store the result of the execution of the IOS XR command. And here in the debug, we say, okay, like print from this value, the lines that are actually resulting from this. So if you look at this red table here, so actually we have very hard-coded, let's say, number of hosts. It's just a single host that we execute some command. So the command is variable, and also credentials are hard-coded, which is, let's say, the kind of a first thing. And I will now go through the slides and go to show you the demo of some more interesting playbooks. So actually, one of the resolution is not that super great, but the command here is Ansible Playbook. First argument is the file playbook file, and here is the argument. So the variable CMD and its value show IP interface brief. And when you do this on the command line, you will see that this is a play that is being executed. So it is the task that's being executed. It has no output. So unless you say that something is printed on the output, you don't get anything printed. It just works. But so we want to let's say we use this to, let's say, get some output. And if you are familiar with IOS XR, you probably saw a lot of this output already. So this is let's say let's say kind of introductory playbooks which show how you can let's say specify the different devices and different parameters, and then we'll go to the, let's say, more interesting stuff. So if we don't want to hard code the host itself, so we can define another variable that's IP address, and provide it as an argument to the playbook, and then execute the host. So here, actually, other than command, we can also give the IP address of the router we want this command to be executed on. And I mean, the output is the same because the command is the same. However, in many cases, you don't want to deal with the IP addresses of the networking devices. You want to use some kind of host names. And then there is a little bit of a problem because the IOS XR command within the provider argument within the host value expects an IP address. So you need to have some kind of mapping of the names or IP addresses. And here, actually, you can build in what is very common in Ansible. So you can build, and you'll see we'll use it also in a couple of cases. So you can specify, let's say, the files which have certain values in there, certain parameters in there, and then these parameters you can include into your playbook, and then your playbook gets some of these values. So here we will define some special. Everything is in YAML. So in Ansible, that's very simple. So in YAML, we'll define the list of devices where each entry has a host name and IP address. And we have some kind of 3 routers, from Silicon Valley, as you could expect. And then we defined the second variable, which is kind of a structure with 2 values, username and password. And if we get back to the device, now we have one additional task. And this task actually deploys a for loop, although you will probably not recognize it if you are not into Ansible already. These with items, this is more or less a loop which go through all the entries of the list devices. When is actually what if is in programming language. So in the programming language, this would be like for device in devices, if you look in the Python. When device host name is actually the host name which will be given as a parameter to the whole playbook, then set the IP address to the IP address which is defined in this list entry. So set fact is probably the weirdest name on earth for setting up a variable with a certain value, but it's like that. The second task is just small help to see if we actually got the right IP address, and the rest you have seen already. So this you can use if you ever would like to use Ansible after today's session for dealing with your network devices as a kind of a starter kit for executing some CLI commands. So it still works on a single host. You can take kind of a task for yourself to develop this for the multi-host, but everything else is a variable. So it's not by IP address, it's by a host name. And actually, this is what we will use. So let's see, for example, how it works. By the way, for the sake of this demonstration, as you probably can see, I'm using Microsoft Windows with the WSL, Windows Subsystem for Linux, which is basically Ubuntu running on your Windows machine. And Ansible is perfectly happy to, let's say, work on, why it doesn't want to copy, sorry, just to speed it up a little bit. Okay, it's from some reason this is not working. Let's then. Oops, sorry. Okay, so -C is a switch where we add the arguments. So the first argument will be host name, and the second argument will be the command. You want some command, special one, or you just use this one? Hopefully the. YAML, sorry. Sorry. Okay. Okay. Sorry. This is why I like to copy more than type, because these things. Sorry? Absolutely, absolutely. Oh, that will be a little harder. Let's see if the font size will be. Okay. Fortunately, I have captured most of these outputs on the slides. For maybe this is the way how we are going to do it. So because it's probably a lot clearer, and it's more or less the same. So it's just a matter of do you believe me that it works or not? But most of this has been captured like yesterday and today morning. So. Okay, so let's go to something real. The something real is how you configure the devices. So actually, you can put simple command by command, but this is not what really automation is about. Let's say how you would probably like to do it is to define some kind of a configuration template, or use the one you have already for configuring this. Parameterize it. And then use Ansible for actually instantiating the correct let's say configuration based on templates and providing this to the network devices. So Ansible uses this Djordje 2 style of templates, which are actually text files with the same double brackets for the certain parameters. And here you can see the templates for putting out one very simple layer 3 VPN service. I hope that most of you are familiar with that. So actually we defined the VRF, we defined some route target. This is in IOS XR. We defined within the router BGP. We define this VRF, route distinguisher, we say redistribute connected. So this is the global configuration for one router. And then you have configuration per interface. So we defined a number of interfaces per certain router, and we said, okay, just said, okay, under one interface, we put it to the VRF, and we assigned IP address. It's very simple. I mean, it's very basic layer 3 VPN, but hopefully good enough. So this is kind of a one example instance that we're using. So layer 3 VPN is the kind of a name, the parameters we use here. So we define the global ones, like VRF name, the AS number, VPN ID, that will be used for constructing the route targets and the route distinguishers. And then we say, okay, we have a list of sites. So each site has a router name, and a list of interfaces. And here I just used Lubex because in some lab that I was using, I mean, I had no C routers connected. So, but it's okay for this example. I mean, you will get the idea. And then you have more or less these two routers. So, if you have super faith in yourself, you can apply this. You can build the playbook which applies this immediately to the router. But in many cases, you would first like to check what is actually how these configurations would look like, or to do some kind of a dry run. So how you can do the dry run in here? So we can use the Ansible module called template, which we saw in the very first example of the Ansible, and says, okay, template as our Ansible as a module gets a Djordje 2 template as a source. As a destination, it is actually a destination file. So what this will create is it will take, let's say, arguments. And the arguments, by the way, so this is how it's been built. You can build it different way. Are taken from the file, and this actually what we do, we give the customer name as a parameter, and then we construct the file name this customer name /layer3vpn.yaml. And from there, actually, we are taking all the parameters that are entering the templates and producing these files. So when you run this playbook, this is how it will look like. The Ansible for each task, you will see actually that you will have this changed, let's say, notion. So the change means that something has been changed. If you read more about Ansible, you will find about this idempotency property of his, meaning that Ansible expects that no matter how many times you deploy some action, the result should be the same. But it knows if there is no result already, so there is no file in here. So change means I created this kind of file. And Ansible created a file for the global configuration on the router SFO, global configuration router Fremont, and for interface configuration on each router. And this is how they look like. So if you just see what the Ansible has done, so it has taken parameters from our parameter file, used the template, and produced this kind of output. And you check this output and say, okay, I'm confident and I can then deliver this to my networking equipment right away. So this is now the real playbook for this configuration. It's more or less the same as the previous one. However, instead of template Ansible module, which produces a file, we will now use the IOS XR config module in here, which actually, so it what actually it does, it first goes to the list of sites you provided, and for each site, it calls this module. And this is a little bit something hard to understand, but you can imagine that it is more or less taking the IP address out of the host name in here, and then deploys this global template. And so this is for global configuration, and this is for the interface configuration. You can see there we have 4 in 4, so it's a kind of loop in loop. So we go first to the sites, and within a site we go through the interfaces. And for each interfaces, we deploy this template. When you run it, and because of the let's look at it that way, it's much better to look black on white than what's in there currently, and to play with the colors. So you get pretty similar output. Actually, now after you run this, all that configuration, if everything is okay, if devices are reachable, if the configuration has no errors, you should be getting out with the this okay or failed will be 0. If you want to check if you actually did something, if this works then you can use the first playbooks we have been building for executing CLI commands to execute some ping VRF into this. And this is, for example, how it can look like if everything is okay. What's the hard part is here? Let's, if we want to say, okay, how we would remove this configuration, how we would delete this configuration. Actually, it is up to you to provide all the configuration which is needed. So here, you would actually have to deploy, to write by yourselves. So Ansible will not help you in that. By yourselves, you will need to write a negative configuration for the global part and for the interface part. Here, it is fairly simple. It might not be that simple in actual environment with a much more complex configuration than you can have. And actually, the playbook for deleting configuration is more or less the same. You just, instead of templates for the creating creating configuration, you just put a template for the deleting configuration. In fact, it would be quite easy to have the same playbook for creating and deleting this service instance, just with a switch which template to use when. And when you run it, it's pretty much the same. I mean, I must say that for me this is not the prettiest output you can get. I mean, out of the orchestration tool, but that's okay. I personally haven't played with the this Ansible Towers GUI, so maybe it looks better in that. However, when speaking about using, if you are a very big fan of Ansible and really you want to use, you're using Ansible a lot for your current applications or operating systems or whatever it is, and you would like to extend it to the networking, there is also one option we have. I don't know how many of you have heard about the Cisco NSO, Cisco Network Services Orchestrator. So this is a platform that we use for the management and provisioning of network devices in the multi-vendor environment. So not only for Cisco, for pretty much for anything. And actually, it has certain properties which can greatly help you deploy Ansible. Actually, these two tools can work in two different ways, depending if you're pretty much application-centric. So, for example, the bulk of your provisioning is about application, and you just have a little bit small piece about the network. Or, and this is more or less something which we are currently concentrating on. This is something which might be developed in the future, and this is, for example, when you have some kind of a networking service, but you have kind of a very small limited part which needs to do something with application. For example, I don't know, I want to configure new, I don't know, domain, or to change some domain on the bind DNS, or put some DHCP subnet in the DHCP server pool, some small amount of things in there. So what you would gain with this approach out of the let's say direct method when Ansible is talking directly to the networking devices. So the NSO itself has a framework or network services, and by some very advanced technology which people created for the NSO. Actually, you define the network service, which can be a layer 3 VPN, and actually we will see this as a kind of example. But you there define only, although NSO will define full, let's say, CRUD possibilities to you, when you create network service, you just put, let's say, the configuration that needs to be put on the device. Let's say when you configure the full service, like we did in the first step. And the update and the delete configuration, what we did manually on the last step on the previous chapter, NSO does automatically. How? The great thing about NSO is if you look at what we did in the first place, actually Ansible didn't have a clue what we were configuring. We were just putting lines of simple text. So it was up to us not to make a mistake on some configuration items or whatever. But if we did, we would get a error message from the IOS XR itself. Ansible will present to us like this command does not exist, or this parameter is wrong, or whatever it is. NSO, on the other hand, has a model of the configuration for almost all popular network operating systems, like Cisco IOS XR NXOS, Juniper Junos, Huawei VRP, Alcatel SRIOS, many other security vendors like Fortinet F5 Checkpoint or something like this. However, so these are all models. So it knows that the command is not a simple clear line of text. It has this argument, which is this type. It is mandatory or optional, something like this. And it has a data model out of what you present. And out of the data model, with some very smart algorithms, it can automatically create a negative, let's say, out of the certain configuration. And you will see how more or less it looks like. The second thing why NSO is good is provides this transaction-wise view. For example, what would happen if, for example, second router was unavailable when running first playbook? So you would deploy configuration of the first router, then you would attempt to do it on the second router, and you would say, okay, second router is not answering, I'm failing. However, the first configuration will be still there, unless you do something manually about it. You can go to device and do the rollback, but you will have to do it manually. Actually, what we here, what is a transaction? Like, I want to have it configured fully on both routers, or if it is not possible, I don't want anything less than 100%. I don't want them to have any kind of a leftovers of my attempts to do something. This is what NSO actually enables you to do. So it has this kind of a network-wide transaction. So it will prepare all the configuration for all the routers. When all the routers are ready, it will start deploying their configuration. If any router fails in this sequence, it will automatically undo what has been provided to the routers previously. So from the end of last year, actually Cisco developed Ansible modules that would enable you to control NSO from the Ansible playbook. And let me show you in a couple of minutes how it works. So this is just a file where we define the basic parameters how to access NSO. You can now think of NSO as a kind of application or something like this, which you access to the API interface. This is the URL for that interface, and these are credentials for accessing it. So this is a very simple playbook for general configuration of something with the NSO. It looks like what we did. So now we have a NSO config Ansible module. We define the URL, username, password. And in the data, we actually define what kind of a configuration we want to put into the NSO. Now the configuration is a bit different because actually, although in the NSO, we can configure also devices directly through the NSO, here we will be actually configuring a layer 3 VPN service that we previously defined within the NSO. And these are the parameters, and you see that it's pretty much looking like the previous ones of the service parameters. NSO service, something odd, something complex, not at all. Actually, in the NSO service, we have the same templates which we had previously, but not in the Djordje 2, let's say, nice format, which we all know. The NSO uses, let's say, formal XML encoding. Why? Because the Djordje 2 deals with the clear text. NSO deals with the object model of the device configuration. He knows the structure. He knows that when you configure the VRF, then you have all the hierarchy of different VRF parameters, or the same for the router BGP. You see that it's very looking like the CLI with some kind of differences. For example, you see this BGP no instance. This is something you don't have in the CLI of the IOS XR. However, this is because the CLIs of the world, Cisco included, were not strictly made adhering to some formal object model. And this is what the people in the formal TLF, from which Cisco acquired this product, actually did. And they're still doing it. And this is the part of the interface configuration. Why the XML templates are actually much better? I did, in some presentations, I do some very simple thing. This Djordje template that we used for configuring IOS XR, I just add a space as the first character, and everything fails. Unfortunately, these modules are, and with the conjunction with the IOS XR, are not that hardened. So yes, they can work, but if you go a little bit left and right, you will very easily come to a certain error. which of course can be troubleshooted, can be fixed. But when you use the formal encoding like XML, you don't have any kind of these problems. And regarding the code that we previously had in the playbook, you remember this 4 in 4 and some. Now we have some pretty simple Python code in here. So this Python code is more or less taking the arguments from the service instance, and now I would say that this is much more readable than for some people, at least for me, than have it on Ansible. I don't have anything, so you see I present you with the both options. But if I have to let's say maintain something, I'll opt for this. And then you run this playbook. What is also different in this case? Actually, if you remember when we were configuring directly with a direct-to-device method, so what we used is actually we did SSH to a device, put a config, end connection. Then SSH to a second device, put config, exit. So actually, and then we got to the Go interface again to the first device. What you will end up with Ansible are these kind of you can end up, depending how you write your playbook, with many different calls to device, and it takes a little bit time. You maybe saw that it will take maybe 20 seconds or something like this based on some configuration. Here actually we have a one call. And what will NSO do? It will combine all the configuration for the single device and put it in the single stroke to the device. And that it will do that for the as many devices as you have. So this is the NSO has also CLI. NSO has a CLI GUI and API. So everything what can be done in NSO can be done in either way. So you can also then check what this service actually configured on the router. NSO has a database in itself, has a database of service instances, and also it is able to remember what certain configuration was put for who put that configuration in the system. For Ansible, actually, you would a little bit have to do it by yourself. Is it possible to execute a kind of a simple command like we did ping VRF from NSO? In fact, yes, because this device driver for the NSO, although the main part is doing the, let's say, configuration part, they can also, using this live status action, execute arbitrary commands. So you can execute shows, you can execute pings, you can execute whatever you want. So actually, in the very similar fashion how we did it for the direct-to-device, we see also say ping VRF something, and then you have pretty much the same output. What you can very much say that, yeah, well, this output is very much unstructured. Yes, it is. This is the text which we just here execute the command and get the same output. So this, let's say, output is unfortunately not structured. If you want, and this is something which is commonly done both in Ansible and in NSO, you use different regular expressions to, for example, find out is this working or not. For example, I don't know, look for the string of 5 exclamation marks or something like that. NSO by itself is keeping the copies of all the configuration to devices, so you can also show the configuration of the device and part of configuration of device by, let's say, also very, this was not this playbook, I'm sorry. But you can also see, for example, the configuration of the networking device. Now, if then we want to remove the layer 3 VPN service, we don't need to provide these special templates for creating negative configuration. We just need to provide to put that within this service instance the state is absent, and this means like remove everything what is there. What NSO will do, so it will, through the Ansible module, it will get the command to kill this layer 3 VPN instance. Killing layer 3 VPN instance, meaning creating negative configuration for each device. And you saw that for this service, it knows what is configuration that he created. And deploying this negative service to each device is again in a transactional fashion. So actually, after this, you get everything. You get everything clear. And the same, like you can probably combine the create and delete playbooks just with a little bit of different names. Hopefully we are on time. The idea of this session was to introduce use of Ansible for managing Cisco devices in a very much practical fashion. You see that there is a number of examples here that you might be using. The iOS will be almost the same as iOS XR, just for you to know. If you would be willing, I can also post these examples to some of the GitHub so that you can download it, or if you want, just, I don't know, give me your business card or piece of paper with your email address, so I can send you probably next week when I put some nice wrapper around this content. Otherwise, enjoy PLNOG, enjoy Krakow, and thank you very much.